So hello everybody. Today we will be learning about waves and Huygens Principle basically. So first, like to tell what Huygens Principle is, we have to define what a wavefront is. So a wavefront is basically an imaginary surface, in space that joins all of the points of a wave. So basically, if you have a whole bunch of waves like this, the wavefront is this planar wave, because this wavefront is a surface that joins all points of the wave together. And this is basically the gist of Huygens principle. This is the gist of Huygens principle. So, uh, let's say we have this planar wave. Say we have this planar wave, and this is what it looks like before. So this is what it looks like before. Okay, just this planar wave. So what will it look like afterwards? So using Huygens principle, we consider every single point in this planar wave as a point source, meaning that at this point we consider it a point source, and then this emits its own wave. And then at this point we consider this as a point source, and this emits its own wave. And it's wavelets. Every single point emits its own wavelet. So the propagation of this planar wave afterwards is the tangent line of all of the planar waves, and then at the end it curves, because at the end there's no tangent. You can't take the tangent line of these circles anymore, because there's no tangent line. So afterwards it will look like a straight line that curves at the end. And then after that, it will look like a bigger line that curves at the end. You see? Because at this point, the wave, like the tangent line, before it could curve here, there's another wave here. Before it could curve at this point, there's another wave here. And then at this point, there's no other wave that will make it go in a straight line, so it curves. So this is basically what Huygens principle is. And first, why do we consider every point source as an individual wavelet? Well, because electromagnetic radiation electromagnetic radiation is basically, it could be produced within oscillating dipoles. And a dipole is basically this it's like basically something where the charges are separated by this infinitesimally small distance. Like you have singular charges with the same amount of charge but opposite signs that are separated by this really small distance. Like inf 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 infinitesimally small distance it's separated by. So when these dipoles, say, so when these dipoles, let's say they're oscillating up and down, if they're oscillating up and down, that means when dipole is moving it up, the acceleration is making it move down. And then when it's moving down, the acceleration is making it moving up. Because, for example, if you have a ball and it's falling, right? The even though no, my bad. If you have a ball and then someone throws it up, the ball ends up falling back down, right? Because as the ball moves up, its acceleration will make it move down. Just like this dipole here, when it's moving up, its acceleration will make it move down, and then when it's moving down, its acceleration will make it move up, and then it will oscillate. So these oscillating dipoles create these accelerating charges. Accelerating charges like causes fluctuating magnetic fields, because as we know, the magnitude of the magnetic field B equals mu times I over 2 pi r. So at a certain instance in time, the magnitude of the current is like could be less or more than the magnitude afterwards. So you have this fluctuating magnetic fields, let's say pointing this way, and then the propagation of the electric field will probably point perpendicular to it, right? So and then and then the fluctuating magnetic field induces the fluctuating electric field, and the fluctuating electric field induces the fluctuating magnetic fields. So as we know, the direction of the flow of this charge, like direction of the intensity, is always perpendicular to the direction of the electric field and the direction of the magnetic fields. So that means if the charge is oscillating, like direction the direction of the wave is always opposite, must be perpendicular to the direction of the electric field. That means uh, the wave will never move in the direction of the electric field. It's almost impossible. So when you have this fluctuating magnetic fields and electric fields, these dipoles, like every single point on the wavefront, you could consider it as the singular dipole that, and then the the frequency of the oscillation is the same as the frequency of the wave. So each each point point source, each point on the wave, you could consider it as the singular dipole that emits these small wavelets. And if you take the tangent line of every single small wavelet, you generate this wavefront. And as we defined before, a wavefront is basically point imaginary surface that joins the waves the that joins like waves in space. This is basically what a wavefront is. So uh, this is basically what a wavefront is. So I so can we give an example? So how does Huygens principle apply to, let's say, refraction? Basically, if you have this car, wait, a different color. If you have a car, right, and this is, let's say you're looking at it from a top view, and these are like the tires or something. Let's say it's moving this way. If you have a car and then this is mud, and this is mud here, when the car as the car moves toward the mud, at this point, when the car moves toward the mud, at this point, the not all of the tires will reach the mud. Only this tire will reach the mud, and all the other tires will be, let's say, outside the mud, right? I kind of drew it bad, but whatever. At this point, the 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 velocity of the tires would slow down, and then this since this tires is slowing down, it would generate the whole car just to curve or move toward the normal. And this is basically a application of Huygens principle, because you could consider each point, like each tire, as a individual point source. So as the tire goes toward the mud, this tire right here would just slow down, and this would generate the whole wave just to curve. Thank you. So in this video I defined what Huygens principle is. In the next video I would use Huygens principle to explain more about diffraction and the equation of diffraction. Thank you very much. This is Fall Academy.